Every single year, more than 200,000 hydrocycles are sold all around the globe. And the overall market for this type of equipment exceeds $2.5 billion United States of America dollars. But how does a piece of composite material turn into a genuine water monster that can accelerate up to 70 miles per hour? What makes the Japanese Yamaha factory the largest hydrocycle manufacturer in the entire world? From automated hull molding to the most advanced engines and on-water testing, today we are going to unveil every secret of their production. Fasten your seatbelts because we are heading into a realm of high speeds and groundbreaking innovations. The design of hydrocycles begins with conceptual ideas and essential requirements for technical specifications. The very first stage involves identifying the target audience and the purpose of the hydrocycle. It can be a recreational model, a sports or extreme hydrocycle, or even specialized versions for fishing or rescue operations. Designers and engineers must consider not only the visual appeal, but also factors such as maneuverability, stability, top speed, comfort, and water safety. They carefully think through each detail so that the final product meets the needs of both beginners and seasoned riders. According to Statista, the global hydrocycle market by the year 2027 will grow to over $2.5 billion United States of America dollars, with an annual growth rate of 8.3%. This impressive forecast shows just how much interest hydrocycles continue to generate in different parts of the world, especially as new technology makes them more efficient, eco-friendly, and fun to ride. One of the biggest markets for hydrocycles is the United States of America, where more than half of all hydrocycles worldwide are sold. This country remains a leader in water sports development, partly because of its numerous resorts, lakes, rivers, and coastlines, which make hydrocycles immensely popular among both local residents and tourists. Hydrocycles are also well liked in Australia and Japan, where water activities are an integral part of cultural traditions, and people love to explore different forms of aquatic adventure. During the development stage, important factors include the design of the hull, which must be light yet strong and resistant to mechanical damage. For this purpose, high-quality materials such as fiberglass, composites, and aluminum are used to achieve the required rigidity without adding too much weight to the hydrocycle. Another critical consideration is the choice of engine. Most hydrocycles use internal combustion engines, although a growing number of manufacturers are experimenting with electric models, which offer cleaner emissions and produce less noise. In modern hydrocycle design, special attention is paid to innovative technologies, including digital control systems, integration of the global positioning system, and sensors for monitoring the condition of the equipment and improving navigation. These features not only make the experience more convenient for the rider, but they also boost overall safety through automatic stability control systems or engine rotation alerts. All of this simplifies the hydrocycle piloting process and makes it safer, even for first-time enthusiasts. The United States of America holds over 50% of the global hydrocycle market. Another notable trend is the rising demand for electric hydrocycles. Although they currently occupy only a small share of the market, their environmental advantages could make them a key part of the hydrocycle industry's future, since they help reduce emissions and lower noise pollution levels on the water. An essential element of design involves creating an ergonomic layout that ensures comfort during lengthy rides or races. Seats must be comfortable and provide proper support for the rider's posture, while also featuring a non-slip surface that holds up in wet conditions. Additionally, hydrocycles are equipped with various features, such as extra storage compartments, waterproof pouches, and cooling systems that help the vehicle operate at high revolutions over long periods. Developing new models also requires numerous water tests to check how the hydrocycle performs in real conditions. This process helps identify any weaknesses in the design or technical parameters, which are then corrected before the start of mass production, guaranteeing that customers receive a high-quality product. The hydrocycle development process is extremely detailed and demands meticulous attention at every phase, from designing the hull to testing the final product. Engineers, designers, And manufacturing specialists must work in close collaboration to produce equipment that is not just powerful and fast, but also safe and comfortable for users. Hydrocycles need to be easy to maneuver on the water, while also having enough durability to withstand heavy loads, water pressure, salt, ultraviolet radiation, and other environmental factors. These stringent requirements mean that the choice of materials for different hydrocycle components must be carefully evaluated to balance weight, strength, and resistance to corrosive elements. First and foremost, a key element of any hydrocycle's construction is its hull. This is one of the main parts that must be strong enough to resist mechanical damage and, at the same time, provide optimal hydrodynamic characteristics. The most common materials for hull manufacturing include fiberglass, composite substances, and aluminum. Fiberglass is selected because it offers high strength at a low weight and is resistant to corrosion, making it ideal for use in aquatic environments. In addition, it can be molded easily, allowing engineers to create sleek, aerodynamic shapes for the hydrocycle hull. Composite materials, which include polymers reinforced with fibers such as carbon or Kevlar, are even more advanced, delivering greater strength while reducing weight. They also exhibit excellent resistance to ultraviolet exposure and chemical agents like salty water solutions. By combining these materials, manufacturers can cut down on hydrocycle weight while improving speed and maneuverability, which is especially beneficial for sports-oriented models. When it comes to internal components, such as fuel tanks and cooling systems, manufacturers often rely on stainless steel or specialized plastic blends. Stainless steel is a long-lasting material that resists corrosion, making it perfect for repeated contact with water and various liquids. Plastic blends, such as high-density polyethylene, are used due to their lightness, durability against chemical and mechanical impact, and ability to function effectively for extended periods in high humidity conditions. Another crucial consideration is the choice of materials for hydrocycle engines. Lightweight yet powerful substances are essential for achieving high revolutions without sacrificing endurance. Typically, engine components are made from metal alloys, including aluminum, titanium alloys, or magnesium. These materials have low density, which helps reduce engine weight, and they have excellent thermal conductivity, which is critical for efficient cooling and overall engine performance. One well-known hydrocycle manufacturing facility is located in Japan, operated by Yamaha Motor Company, which is widely recognized as one of the leading brands in the watercraft market. Situated in the city of Iwata in Shizuoka Prefecture, this factory produces not only hydrocycles, but also other types of water transport and their engines. The Yamaha Motor Factory spans approximately 250 acres, making it one of the largest facilities in the world dedicated to water equipment production, including hydrocycles. The site specializes in manufacturing a broad range of water transport products, including diverse hydrocycle models, boats, yachts, and other motorized water vehicles. Every year, this factory turns out thousands of products, including over 60,000 hydrocycles annually, which secures Yamaha a substantial market share in the water transport sector. Thanks to the factory's expansive premises, every stage of production, from assembly to testing and packaging, can be carried out efficiently and in one location. One of the main automated lines is responsible for forming hydrocycle hulls using materials such as fiberglass and composites. This line is equipped with robotic arms that precisely shape and join individual hull components, delivering the exact design contours and a smooth exterior finish. In addition, automated welding and painting systems are used to process metal parts, such as engines and their subsystems. The line features robotic welding machines that provide accurate, high-quality welds, as well as automated painting systems that evenly coat components and offer reliable protection against corrosion. This advanced technology helps ensure the product maintains a pristine appearance and robust structure over an extended service life. The assembly lines have a real-time quality control system, which automatically identifies defects at any stage of production. This includes visual inspections using cameras and scanners capable of detecting even the smallest flaws in parts, allowing the factory to preserve the highest possible product quality. A distinctive feature of this factory is its extensive automation in the packaging and shipping phases. Once hydrocycles have passed all quality checks, they move on to automated packaging lines, where robotized systems assemble boxes and secure the hydrocycles inside transport containers. This process enhances shipping safety and streamlines logistics, ensuring that the products are delivered to customers in excellent condition and on schedule. The Yamaha factory continuously adopts the latest technologies in water equipment production. For instance, they use three-dimensional printing to create prototypes of new models, enabling faster testing and refinement of their designs. Moreover, the facility employs pioneering materials that help reduce the weight of hydrocycles, increase their corrosion resistance, and extend their service life. They also make active use of intelligent production management systems, which optimize manufacturing processes, cut down on costs, and shorten the time needed to produce each unit. As a result, the factory can expedite hydrocycle manufacturing and boost output volume, illustrating Yamaha's commitment to continuous innovation and leadership in the fast-paced world of hydrocycle development. Every single year, more than 170 million old refrigerators are disposed of throughout the world. However, what actually happens to them once they disappear from our kitchens? Refrigerants that can damage the ozone layer, hundreds of pounds of metal, plastic, and even precious metals all require specialized processing. Did you know that old refrigerators contain gold, silver, and copper that can all be given a second life? And some models are even sold to poorer countries instead of being recycled. Please stay with us to see how junk is turned into a resource and discover who is making millions of dollars in the process. In the United States of America, there are several ways old refrigerators are collected for disposal, ensuring safe and environmentally responsible recycling. Some large retail chains, such as Best Buy, offer programs to recycle old household appliances. When you purchase a new refrigerator, they can take the old one away for further recycling. These programs often come with restrictions, for example, no more than 3 appliances per day from a single household. There are a few reasons for limits on how many appliances can be recycled. The first reason is logistics and the burden on the system, since recycling centers have limited capacity. If everyone could drop off any number of appliances, the collection and recycling processes could become overloaded. These programs are also intended for individual consumers, not for businesses or resellers. The limits also prevent hauling companies from making free use of disposal services. The third reason concerns cost optimization. In many cases, recycling is subsidized by the government or by private companies. The restrictions help control expenses and distribute resources evenly. The final reason is environmental responsibility. These programs often encourage people to switch to energy-efficient devices rather than simply throwing away large quantities of appliances. It is a kind of balance between convenience for consumers and the operational efficiency of the recycling centers. In many cities and districts, there are municipal collection points for large household appliances. Consumers can bring their old refrigerators to these points, where specialized companies pick them up for recycling. These collection points can be stationary or mobile, which makes it more convenient for residents. Some energy companies also offer programs for disposing of old, inefficient refrigerators. They may provide financial incentives or free appliance removal to encourage consumers to switch to energy-saving models. There are also private companies that specialize in collecting and recycling large household appliances. They offer services to remove old refrigerators directly from the consumer's home for a certain fee. These methods of collecting old refrigerators support the responsible handling of electronic waste, ensuring proper recycling and minimizing negative impacts on the environment. After collection, old refrigerators are taken to specialized recycling centers, where they are sorted and prepared for disposal. This process unfolds in several main ways, which we will describe right now. Many major cities have specialized facilities that accept old appliances directly. For instance, in the United States of America, such facilities operate under programs focused on the responsible recycling of electronics. In some situations, refrigerators are first sent to warehouses or designated lots where enough units are accumulated for subsequent mass recycling. This saves on transportation costs and streamlines logistics. Some large brands, such as Whirlpool or LG, run their own recycling programs. They take back old refrigerators, break them down, and reuse some of the materials in the production of new appliances. Sometimes, old but still functioning refrigerators are sold or transferred to less developed countries. This practice is considered controversial because such equipment can consume a lot of energy and may contain hazardous substances. How do you feel about this issue? Is it better to have a refrigerator that poses potential harm, or is health more important than questionable humanitarian aid? In Europe, there are strict regulations regarding the recycling of household appliances. For instance, under the Waste Electrical and Electronic Equipment program, refrigerators are transported to certified centers, where they are taken apart into environmentally safe components. At every stage of this process, safety regulations must be observed, because refrigerators contain refrigerants and other potentially harmful substances that cannot simply be dumped in a landfill. Before a refrigerator is sent for dismantling, its technical condition is assessed. Models that still work can be repaired and resold, or donated to charitable organizations. Faulty or obsolete models are immediately directed to further processing. Next, refrigerators are categorized, since different models contain different materials and refrigerants. They are divided into industrial refrigerators, household refrigerators, and refrigerators containing harmful freon. After that, refrigerators are checked for the presence of hazardous gases and liquids. Freon and other refrigerants are removed because they require special disposal methods, as they deplete the ozone layer. Lubricants are drained, since they can contain heavy metals. Before extracting freon, technicians place the refrigerator in a designated treatment area, where they check which specific refrigerant is used. Technicians connect the refrigerator to a vacuum pump, which creates pressure inside the system and forces the freon to flow in the required direction. The refrigerant is drawn out through specialized valves, after which the gaseous freon is collected in sealed containers, while the liquid freon is filtered and can either be used again or sent for chemical recycling. The freon that is collected undergoes purification to remove oil, moisture, and metal particles. After that, it is either destroyed or reused in cooling equipment. Older banned refrigerants must not be released into the atmosphere, so they are incinerated in special high-temperature installations that break them down into harmless components, or they are converted into newer, safer gases through chemical reactions. All of this happens at certified facilities because mishandling freon can cause damage to the environment. Once the freon and other refrigerants have been dealt with, it is necessary to drain the lubricants from the refrigerator. These fluids contain pollutants that can harm the environment. The lubricant in a refrigerator is mostly in the compressor, which is responsible for circulating the refrigerant. During operation, it mixes with freon, so removing both substances often occurs simultaneously, although it depends on the specific model. Before draining the lubricant, the compressor is removed or punctured so that the fluid can flow out freely. The lubricant then either drains by gravity into a collection tank, or it is pumped out by a vacuum device. Special containers are used to prevent spills and the evaporation of dangerous substances. The collected fluid is then purified of any remaining freon, metal particles, and other impurities through settling and filtration. After purification, the lubricant can be reused in compressors if additional cleaning is performed. If it cannot be recycled, it is incinerated in special furnaces. It can also be applied in certain industries, for instance, in the production of technical lubricants. This is carried out at specialized facilities to prevent leaks of harmful substances into the environment. Modern refrigerators contain electronic boards, displays, and battery elements. Workers remove these parts by hand because automated conveyors cannot handle such components without damaging valuable materials. Prior to shredding, refrigerators undergo inspection. Wiring, plastic parts, and insulating panels are taken off. These materials are sorted for further recycling or safe disposal. In general, human oversight is required at every step to ensure safe and clean disassembly. However, certain processes are automated. For example, shredding metal housings or compressing plastics. The external body of a refrigerator is usually made of steel or aluminum sheet. It is separated either by hand or by hydraulic machines and sent for shredding. Compressors and condensers have a high content of non-ferrous metals, such as copper and aluminum, so they are taken apart separately. Copper and aluminum are then sent for smelting and used in new electric devices. Refrigerators also contain many plastic parts, such as internal panels, shelves, bins, and door gaskets. Workers remove these elements by hand because the plastic must be sorted by type. Certain types of plastic are recycled into pellets, which are later used to manufacture new products. Some refrigerator models feature glass shelves or glass doors in display-style refrigerators. This glass is removed manually, sorted by quality, and sent for remelting. Modern refrigerators include control boards, displays, wiring, and batteries. Electronic parts are taken out and transferred to specialized facilities for extracting precious metals like gold, silver, and palladium. Most refrigerators have foam polyurethane or polystyrene foam as insulation. It is removed or shredded, and some of that material can be used as filler in construction or for manufacturing new insulation. Metals go to metallurgical plants. Plastics are compressed into briquettes and sent to recycling facilities. First, the plastic parts, meaning bins, shelves, and outer components, are placed into special shredders. Inside these machines, blades or rotary cutters chop the plastic into tiny pieces no more than 2 inches in size. Next, the plastic fragments are washed in water baths to remove dust, adhesive residue, labels, and other impurities. Some plastics undergo separation, during which they are divided by density. For example, lighter polymers float to the surface, while heavier ones sink to the bottom. The cleaned plastic is sent through powerful drying units to ensure it has no excess moisture, since moisture can reduce the quality of the recycling process. The dried plastic is then fed into hydraulic or mechanical presses, where it is compacted under pressures of up to a few hundred short tons. This process occurs without heating, so the material does not melt but simply becomes more dense. The pressed plastic is formed into briquettes weighing from a few pounds to a few dozen pounds, depending on what clients need. The finished briquettes are wrapped in film or secured with metal straps so that they do not fall apart during transport. They are then shipped to factories where the plastic will be melted and converted into new items such as plastic containers, furniture, pipes, or even parts for new refrigerators. This method conserves space during transport and reduces logistics costs, since pressed plastic occupies several times less volume than loose fragments. Glass is remelted and used in new glass products. Electronic parts are recycled separately, and precious metals are extracted from them. Insulation materials are partly disposed of or reused. Thanks to modern technology, most materials from old refrigerators get a second chance at life. Every single year, the world's oceans are left with hundreds of gigantic liners that used to be floating cities. Imagine this. Only one specialized shipyard in the country of India dismantles over 400 ships per year, and the utilization of just one cruise liner can yield up to about 44,000 short tons of steel. How does a vessel that once cost billions of dollars turn into a heap of scrap metal? Who makes money on this process? And why do the majority of ships finish their journey in southern Asia? Let us examine this process from the very first blueprint all the way to the very last cutting of the hull. Private yachts are produced all over the world, including in the United Kingdom, the Netherlands, Italy, and Turkey. But the major cruise liner production hubs are located in France, Germany, Italy, and Finland, where industry giants such as Chantier de l'Atlantique, Meyer Werft, and Fincantieri operate. Everything begins with the creation of a project, during which engineers and designers develop the overall structure, choose materials, and determine the technical specifications of the vessel. The design phase can last anywhere from 6 months to 5 years. Once it is approved, the shipyard begins manufacturing the main metal sections of the hull, which are later joined together in a massive dry dock or a specialized construction hangar. Construction starts with the production of large steel or aluminum sections that will form the hull. First, enormous sheets of metal are cut using laser or plasma cutting, and then they are joined by welding to create separate blocks. Each block can weigh anywhere from about 55 short tons to about 330 short tons. and their total number may reach into the hundreds, depending on the ship's size. After the welding is completed, the sections are painted with anti-corrosion coating and moved into a massive assembly dock, where the hull begins to take shape. The assembly process involves powerful cranes that lift the blocks and connect them to one another. Once the main structure is finished, the hull is reinforced with internal bulkheads, and initial communications are installed, including piping systems, ventilation ducts, and electrical cables. When the hull is fully assembled, it is launched into the water, and the fitting out of the interior begins. Partitions, electrical grids, heating and ventilation systems, air conditioning, and safety systems are put in place. At this stage, the ship gradually starts to look the way it will when it is completed. First, special soundproofing and thermal insulation materials are applied to the ship's metal hull, because the liner must be not only strong, but also comfortable. Next, metal frameworks are installed to serve as the foundation for the partitions and other structures. These frames are made of lightweight materials, such as aluminum or composite panels, to keep the vessel's overall weight lower. Thanks to modular technology, large sections of cabins and public areas are assembled at separate production facilities and then transported to the liner, where they are rapidly installed. Passenger cabins are usually manufactured as complete blocks, each including walls, flooring, plumbing, and furniture. These blocks are then transported to the ship and placed in their designated spots, after which they are connected to the ship's electrical network and water supply and ventilation systems. Larger liners can have more than 2,000 of these modules, and installing them can take several months. Public areas are much more complex, since each restaurant, theater, or lobby has its own design and intricate architectural solutions. For example, theater stages are equipped with moving platforms, sound systems, and lighting that is integrated into the ceiling. Swimming pools receive water purification systems, and sports courts are fitted with special non-slip surfaces designed to withstand wave movement. During the final stage, furniture, decorative panels, lighting, and finishing touches are installed. High-quality materials are used, ranging from exotic woods and marble to stained glass. Designers pay attention to every single detail in order to create an atmosphere of luxury and comfort. Once construction is complete, all systems undergo meticulous testing, including elevators, ventilation, safety features, and communication lines, so that the liner is fully prepared to welcome passengers. At the same time, powerful engines and control systems are installed on board. The main engines, which are typically diesel or hybrid, are mounted in the engine room before the liner's hull is completely enclosed. Each engine can weigh anywhere from about 22 short tons to about 55 short tons, and there may be between 3 and 6 engines depending on the ship's size. They are delivered to the shipyard dock by specialized cranes, then lowered through the engine room's top hatch and attached to vibration-damping mounts that reduce noise and vibration during operation. After the engines have been installed, drive shafts are added to transmit rotational motion to the propellers, or, in the case of electric motors, they are connected to the power supply system. Most modern liners use azipod units, which are powerful electric motors capable of rotating around their own axis, giving the ship excellent maneuverability. All power units are connected to control systems located on the bridge and in the engine room. Once every technical system is in place, the liner is readied for its initial tests. First, static tests are conducted while the ship is still in the dock, checking how the engines function without leaving port. The power units are started up, and the electrical supply, fuel pumps, cooling systems, and emergency mechanisms are tested. Computerized control systems, which manage navigation, automatic speed adjustment, and ship stability, are also checked at this stage. Following these static tests, the liner is launched for sea trials, which last from about 2 weeks to about 6 weeks and include checking speed, maneuverability, and the operation of all systems under real-world conditions. The captain and technical personnel test how the vessel responds to commands, examining braking efficiency and the performance of the stabilization systems. The liner is taken into open waters, where the engines are tested at maximum power. Fuel consumption is measured, and noise and vibration levels in cabins and public areas are evaluated. In the final phase of testing, safety systems are examined by simulating emergency scenarios, testing firefighting systems, lifeboats, evacuation routes, and communication with shore-based services. Only after all tests are successfully completed is the liner formally handed over to the client, and it sets sail on its maiden voyage. But sooner or later, every liner heads out on its last voyage. Since no technology lasts forever, what happens to yachts and other vessels afterward? Are they actually utilized? And if so, how? According to data from the International Maritime Organization, around 1,000 seagoing vessels are utilized each year, of which about 200 are large cruise liners and passenger ships. Most of these vessels are dismantled in South Asian countries such as India, Bangladesh, and Pakistan, where the world's largest ship utilization shipyards are located. For instance, in the city of Alang in India, there is one of the biggest shipyards, which processes over 400 ships per year. First, the ship's owner assesses the condition of the liner and compiles a list of materials that can be recycled, sold, or require specialized disposal. The utilization of a single large cruise liner can produce up to about 44,000 short tons of steel, which, after recycling, is used in construction and other industries. In addition to metals, other materials such as wood, glass, and plastic are removed from the vessels for recycling or safe disposal. During this period, the ship heads to the specialized shipyard that handles the disassembly of ships. The largest of these facilities are located in India, Bangladesh, Turkey, and Pakistan. The liner or yacht makes its way to the site for utilization under its own power, or is towed if its engines are no longer functional. When the vessel arrives at the shipyard, the preparatory work begins. A team of engineers and environmental specialists evaluates the potential risks connected to hazardous substances, including fuel, lubricants, coolants, chemicals, asbestos, and lead. All of these materials must be carefully removed to prevent environmental contamination and to protect the workers' safety. In the first step, any remaining diesel fuel is pumped out of the tanks, which can amount to anywhere between about 10 short tons and about 55 short tons, depending on the size of the vessel. Next, the pipelines, oil filters, and engine cooling systems are cleaned to remove all residual lubricants and chemicals. Specialists also deal with air conditioning and firefighting systems, which might contain harmful gases like freon. After that, the ship is disconnected from all power. The electrical networks are shut down, and the batteries containing toxic substances are removed. In the engine room, the generators are dismantled. They can be resold or used on other ships. During this period, specialists also check for hazardous materials, such as asbestos, which was once used for pipe and wall insulation. Asbestos is carefully taken out, sealed, and delivered to specialized facilities for safe disposal. The next step involves removing all equipment and items that might be reused or sold. Furniture, lighting fixtures, plumbing, doors, decorative panels, carpets, and even kitchen appliances are dismantled from the liner. Many of these items are sold on the secondary market or used on other vessels and in hotels. The following stage is dismantling. First, the ship is secured in a dry dock or pulled onto a specially designated beach, which is common in South Asian countries such as India or Bangladesh. This stabilization is necessary to keep the hull steady during cutting because losing balance could cause an accident. Next, the upper structures are gradually taken apart, including the top decks, bridge, funnels, and other external components. These sections are typically removed in large pieces using cranes. Workers start dismantling the upper structures and decks, steadily moving down toward the main hull. Metal parts like steel and aluminum are cut into smaller segments, and the separated materials are sorted and prepared for subsequent recycling. For example, steel is melted down to create new products, while non-ferrous metals such as copper and aluminum are put to use in various industries. When the upper structures have been fully removed, the main hull is cut apart. Several methods can be used, depending on the thickness of the steel and where the ship is located. The most widespread method is gas cutting, where specialized torches heat the metal to over 1,500 degrees Celsius, which is about 2,732 degrees Fahrenheit, and then the steel is sliced by a stream of oxygen. For thicker steel sections, which can be up to about 8 inches thick, plasma cutting or hydraulic shears may be used. Cutting of the hull begins from the top and proceeds downward so that the structure does not collapse under its own weight. huge steel blocks, weighing anywhere from about 55 short tons to about 110 short tons, are separated and moved to specialized areas, where they are further broken down for recycling. On average, the hull of one large cruise liner can yield from about 33,000 short tons to about 44,000 short tons of steel, which is later reused in construction and shipbuilding. Special attention is paid to cutting the underwater part of the hull, since it is the sturdiest section and contains ballast tanks that might hold residual water. Underwater welding and cutting techniques are employed if part of the hull remains in the water at that stage. In the final phase of dismantling, the last remains of the keel and bottom are cut into fragments, which are loaded onto trucks or barges for transport to metallurgical plants. Utilization of cruise liners and yachts can last from a few months to more than 1 year, depending on the vessel's size and construction. Completing the dismantling process signifies that the ship officially ceases to exist. All materials suitable for reuse are sent for recycling, and everything else that cannot be repurposed is disposed of in accordance with environmental regulations. It is important to note that the utilization process must meet international environmental standards. Organizations such as the International Maritime Organization develop guidelines and standards for the environmentally sound utilization of ships, known as the Hong Kong International Convention for the Safe and Environmentally Sound Recycling of Ships. Every year, over 150 million carats of diamonds are mined worldwide. But did you know that some mines are so deep that the temperature inside exceeds 110 degrees Fahrenheit, and powerful explosions can cause seismic tremors felt up to 50 miles away? Diamond mining isn't just digging. It's a full-scale scientific operation that starts with satellite analysis and can last for decades. How are these precious stones found? How do drilling rigs reach depths of 10,000 feet? And what happens to diamonds after they're mined? Let's break it down together. Diamonds form deep beneath the Earth's surface and are brought up through volcanic processes that create kimberlite pipes. These pipes, made of ancient igneous rock, are the primary sources of diamonds and can reach depths of over 10,000 feet, with temperatures inside the mines exceeding 110 degrees Fahrenheit. To cool these environments, powerful ventilation systems compress air. In some mines, the air is so pressurized that if a door between compartments is suddenly opened, the wind force can knock a person off their feet. Sounds dangerous, right? Before mining begins, geologists conduct extensive exploration that can last for decades. The process starts with analyzing satellite images and aerial photography. This is followed by field studies, where geologists collect rock samples for chemical analysis. Special attention is given to the presence of indicator minerals like garnets, ilmenite, and pyrope, which suggest the potential presence of diamonds. If the exploration yields positive results, detailed surveying begins. Drilling rigs create boreholes up to 10,000 feet deep, extracting core samples, cylindrical sections of rock. These samples undergo thorough laboratory analysis to assess the diamond content in the rock. Geophysical methods like magnetic surveys, electromagnetic scanning, and gravimetry are used. Open pit mining is employed when the deposit is relatively close to the surface. Underground mining is used if diamond-bearing rocks are located at significant depths. Mine shafts are constructed, allowing workers and equipment to descend. Mining begins with drilling boreholes into the kimberlite rock. For this, massive drilling rigs over 50 feet tall are used. Each borehole can reach lengths of 2,000 feet, and a single mine may have tens of thousands of such holes. After drilling, explosives are placed in the boreholes, and the detonation occurs under strictly controlled conditions. Some diamond mines use such powerful explosives that underground blasts can trigger minor seismic tremors detectable over 50 miles away. First, vertical shafts are dug, reaching depths of over 10,000 feet. The diameter of the main mine shafts often exceeds 20 feet. Additionally, horizontal tunnels are constructed, stretching for several miles. After the explosion, the rock in the mine breaks into pieces of various sizes, from large boulders to fine gravel. Powerful loaders with buckets lift the debris and transport it to central transfer points. Here, massive dump trucks, each capable of carrying over 250 tons of rock, load the extracted material and deliver it to the main tunnels. In some mines, instead of trucks, specialized electric trains running on tracks tens of miles long are used, capable of transporting over 500 tons of kimberlite rock per trip. The main tunnels are equipped with conveyor systems that start at depths of several thousand feet and extend to the surface. The length of these belt conveyors can exceed 15 miles, with belt widths over 6 feet. Some systems have multi-level structures, allowing simultaneous material transport from different parts of the mine. Before being placed on the conveyor, large rock fragments pass through crushing stations, where massive steel rollers over 20 feet long break the debris into fragments no larger than 3 feet in diameter. The crushers operate with compressive forces of tens of thousands of pounds per square inch and can process over 10,000 tons per hour. After initial crushing, the material is loaded onto the main conveyor belts, which transport it to the washing system. In some sections, the conveyors pass through special grottos equipped with giant sieves with holes of various sizes. During transport, smaller rock particles are sifted and directed to separate processing lines, while larger pieces move to the next stage of crushing. The newest mines are equipped with automated control systems that analyze the rock composition in real time and adjust conveyor speed and crushing intensity. As the future diamonds approach the surface, they are fed into special bunkers where the rock accumulates, ready for further processing. The capacity of these bunkers can exceed 100,000 tons, and their structure allows for even material distribution to washing and sorting facilities. In mines located in deep regions, transporting the rock can take several hours, with annual extraction volumes reaching millions of tons. When I was a kid, my family loved going to the beach. It didn't happen often. My dad rarely had time off. But when it did, everyone was thrilled and happy. Diving underwater to find seashells, crabs, or even clams, I never imagined that diamonds could be mined from the sea. Deep sea diamond mining is one of the most complex and technologically advanced methods in the mining industry. Mines are located where kimberlite pipes or alluvial deposits lie beneath the ocean floor at depths exceeding 500 feet. Geologists begin by conducting surveys using underwater drilling rigs. These rigs are stationed on specialized offshore platforms or vessels equipped with computerized navigation systems for precise positioning over potential deposits. Once diamond-bearing deposits are confirmed, the construction of an underwater mine begins. This is a complex process involving the creation of sealed tunnels or the use of massive drilling capsules operating under high pressure. One method involves using giant seabed drilling complexes, which can exceed 200 feet in length and weigh over 5,000 tons. These complexes are equipped with diamond-tipped drills capable of cutting through even the hardest rock. During drilling, a specialized hydraulic system creates a water flow under pressures exceeding 3,000 pounds per square inch, washing out small rock particles and diamonds into special reservoirs. Another method uses giant underwater vacuum systems that can descend to depths of up to 1,000 feet and suck up hundreds of thousands of cubic feet of rock per hour. The material is then brought aboard a vessel or platform for initial processing. Special underwater crushers can process up to 50 tons of kimberlite rock per hour. Powerful pumping systems are used to transport the rock to the surface, capable of moving up to 1 million gallons of water per day. Streams of enriched rock are directed through pipelines that can stretch for several miles. The material then enters large sorting tanks, where it passes through gravity separators. Heavier diamonds settle at the bottom, while lighter particles are washed away and returned to the sea. Remotely operated underwater vehicles play a crucial role in deep-sea mining, operating at depths of up to 10,000 feet. They are equipped with manipulators that can precisely collect large diamonds directly from the seabed. Their high-resolution cameras allow operators, located hundreds of miles away, to control the process in real time. Deep-sea mining is so complex and costly that only a few countries in the world have the necessary technology. It can cost hundreds of millions of dollars, and the full mining cycle can take over 10 years. Despite the challenges, this method yields millions of carats of diamonds annually, supplying the global market with precious stones hidden in the ocean's depths for billions of years. On the surface, the extracted rock is crushed in processing plants, where massive steel jaws over 20 feet long break the stones into fragments smaller than 2 inches. Each plant can process over 10,000 tons of material per day. After crushing, the rock passes through a series of washing tanks filled with water and chemical reagents. Diamonds, which have high density, settle at the bottom, while lighter minerals are washed away. Once the material is on the surface, specialized X-ray separators are used to identify diamonds based on their ability to fluoresce under ultraviolet light. Magnetic separators work by exploiting differences in the magnetic properties of materials. Diamonds are non-magnetic, while most minerals in kimberlite rock have weak magnetic properties. In these systems, the rock is fed onto rotating drums over 20 feet long, which generate strong magnetic fields exceeding 10,000 Gauss. Magnetic mineral particles stick to the drum's surface and are removed into a separate container, while diamonds and non-magnetic rock residues move forward. X-ray systems are used in the next stage, when the rock is already significantly purified. These systems rely on diamonds' unique ability to fluoresce under X-ray radiation. The stones enter a special tunnel where they are exposed to X-rays with energies of up to 200 kiloelectronvolts. The diamonds begin to glow, and highly sensitive optical sensors instantly detect their location. The system then activates a high-speed air jet operating at pressures exceeding 100 pounds per square inch, which literally blows the diamonds out and directs them into a collection container. The cleaned diamonds are sorted by size, quality, and color. The sorting process is fully automated and managed by operators in specialized control centers. Each operator monitors dozens of X-ray systems using high-resolution computer panels. Modern systems use machine learning algorithms that can adjust equipment parameters in real time for maximum efficiency. If malfunctions or deviations occur, operators can manually change settings or redirect material flows for reprocessing. A single system can process up to 20 tons of material per hour with precision that detects even the tiniest diamonds smaller than 1/10 of an inch. At large diamond mines, dozens of such systems operate simultaneously, extracting hundreds of millions of carats annually. After sorting, the diamonds are sent for cutting, where artisans use lasers and mechanical tools to transform them into precious gemstones. Once cut, they enter the market, sold as part of jewelry or used for industrial purposes. Did you know that over 3 billion cans of preserved peaches are produced globally every year? But how do peaches go from orchard trees to perfect slices in syrup that we all love? From harvest to sealing freshness in cans, this is a high-tech process where every second counts. Imagine a factory filling up to 30,000 cans per hour. Ready to peek behind the scenes of this amazing production? The journey of canned peaches begins in meticulously cared-for orchards. And here is something important. Specific varieties of peaches are chosen for canning. Picture a tree bred to prepare its fruit for a long life in a can. These peaches are cultivated with taste, firmness, and shelf life in mind. They are not just pretty, they are strategically important. These orchards are typically located in regions with warm climates and plenty of sunshine. Peaches love the sun. It is like their secret ingredient. The main peach-growing regions are found in areas with mild and warm climates. California, Georgia, and South Carolina lead the United States in peach production. Among other countries, Italy stands out, especially northern Italy, where a combination of mountains and valleys creates the perfect climate. China is another major global producer. Peaches are grown in nearly all its provinces. Depending on the country, peach orchards can range from a few acres on small family farms to hundreds of acres for industrial producers. In California alone, orchards designated for canning peaches span over 25,000 acres. In Italy, the total area for peach cultivation is approximately 170,000 acres, though not all are used for processing. Growing peaches is a true art. Here are a few key challenges. While peaches thrive in warmth, severe frost can destroy buds or even entire trees. Therefore, cultivating peaches requires careful selection of varieties suited to the local climate. These trees need regular irrigation, but too much water can cause root rot. Fungal diseases like leaf curl and pests such as aphids require constant monitoring and treatment. Peach trees also need annual pruning to ensure optimal fruit growth. This is a complex but essential process. Additionally, peaches must ripen on the tree to be sweet and juicy, but they cannot overripe, as they become too soft for transportation. This means harvesting occurs on a very tight schedule. Most orchards for canning work with peach varieties that have slightly thicker skins and firmer flesh. This allows them to better withstand processing and transportation. Some farmers grow organic peaches, free from pesticides and chemicals. This is more challenging, but results in a premium product that is increasingly popular. Caring for peach orchards is not just work, it is a science. And though it is not easy, the result is fragrant, juicy peaches that we can enjoy even on cold winter days. Harvesting peaches can be mechanized. Tractors with special shakers gently shake the trees, and the fruits fall onto special mats. However, the most delicate varieties are harvested by hand to avoid damage. Did you know that every picked fruit reaches the factory within 24 hours? Here, every minute is worth its weight in gold. Once the peaches are harvested, their journey has just begun. Transporting them to the factory is a crucial stage because these fruits are incredibly delicate. To preserve their appearance and quality, strict rules must be followed. Right in the orchard, the harvested peaches are usually sorted. Damaged or overripe fruits are discarded as they can spoil during transportation. Peaches are packed into small boxes or plastic containers designed to minimize pressure. Often, they are lined with soft materials to avoid damage during transit. Since peaches spoil quickly, they are delivered to the factory as soon as possible, usually within a few hours of harvest. Factories are often located near the orchards to reduce travel time. Refrigerated trucks maintain temperatures at a maximum of 40 degrees Fahrenheit to slow the ripening process and reduce the risk of spoilage. In large operations, specialized systems gently move the fruits into containers. This reduces the risk of mechanical damage and minimizes manual labor. Every minute counts. If the peaches are delayed, they can begin to spoil or lose their appearance. Excess moisture can lead to rot, while insufficient moisture can cause the fruits to dry out. Therefore, containers and vehicles are equipped with systems to regulate these parameters. Each peach is, essentially, a delicate fruit that is easily damaged. Thus, they are packed carefully, with no unnecessary pressure. In some countries, like Italy or the United States, orchard owners use electric mini-tractors to transport fruits from the orchard to intermediate storage. This is more eco-friendly and convenient. Farmers sometimes organize delivery at night or early in the morning when it is cooler. This helps keep the fruits fresh until they reach the factory. In large operations, transportation containers are labeled, so the factory knows exactly which orchard each batch came from. This helps track the quality of every harvest. As soon as the truck with peaches arrives at the factory, the fruits are immediately inspected for freshness and integrity. Those that pass inspection are sent to the first processing stage, washing and cleaning. And yes, this process happens as quickly as possible because freshness is the key to perfect canned peaches. Workers or automated systems quickly inspect the fruits to remove damaged, rotten, or overly ripe ones. Large operations use optical scanners to analyze the external appearance based on color, shape, and defects. Honestly, I would already be exhausted by the endless inspection, and this is just halfway through the peach's journey to store shelves. Even with modern technology, the human factor remains critical. Operators stand by the conveyor belt and pick out fruits that fail the automatic check. Sometimes, only a human eye can catch subtle defects. The fruits are weighed since overly small or underdeveloped ones may not meet canning standards. Washing is not just rinsing with water, but a full-fledged technological process. Peaches are harvested in orchards, where they can pick up dust, soil residues, or even chemical plant care products. After inspection, the fruits enter special rotating drums, where they are gently rinsed with water. Warm water with mild cleaning agents is used to remove even the smallest particles of dirt. Before peeling, peaches are rinsed again, this time with clean water without any additives. By the way, this entire process takes just a few minutes. Next, peaches are immersed in hot water or exposed to steam for a few seconds. This softens the skin, making it easy to remove. This method also helps preserve the texture of the flesh. Then, the peaches go to special machines equipped with rotating brushes or knives that carefully peel them. The goal is to avoid damaging the fruit and preserve as much flesh as possible. The next step involves removing the pits. Special devices carefully cut the peach in half and extract the core. But even here, there are nuances. Some peaches, known as clingstone, have pits that cling tightly to the flesh. These require more precise equipment. Peeled peaches undergo a final check to ensure the skin is completely removed and the fruit's shape is intact. This is especially important for canned peaches made from halves or quarters. After peeling, peaches are cut into halves, slices, or even cubes, depending on their intended use. Here, specialized machines with incredible precision come into play. Did you know some factories have blades that can slice peaches faster than you can blink? Even so, each slice is manually inspected to ensure no defects are missed. Next, the peaches are placed in cans and syrup is added. Depending on the recipe, the syrup can be light, medium, or thick. The most interesting part is that some recipes use special flavorings to enhance the taste of the peaches, and this is the detail you definitely notice when you open a can. The cans are sealed and immediately pasteurized. This means they are heated to high temperatures, which lock in freshness. During pasteurization, canned peaches are heated to approximately 200 degrees Fahrenheit. This temperature range is high enough to destroy harmful microorganisms, preserve the product's freshness, and extend its shelf life, but it does not affect the taste or texture of the peaches. By the way, the entire process takes just a few minutes, leaving no chance for bacteria. The speed of filling cans can reach from 3,000 to 30,000 cans per hour. This demonstrates the high level of automation and efficiency in such productions. After cooling, the cans are sorted, labeled, and sent to warehouses. Sometimes, they even undergo additional inspections, to make sure everything is perfect. Then these cans are shipped to stores worldwide. Did you know the United States, China, and Greece are the 3 largest producers of canned peaches? Additionally, global tasting competitions are held to select the best syrup. Yes, this industry has its own Oscar. So next time you open a can of peaches, remember how many people and machines work to bring this dessert to your table. You know what? They really nailed it. This was the most unusual tour in the history of this channel. When I first heard about the EnviroFlight farm, a place where they grow black soldier fly larvae for animal feed, I imagined something straight out of science fiction or a horror movie. But what I saw wasn't just fascinating, it was revolutionary for the future of feed. I never thought raising flies could be this exciting. Yes, you heard that right. Flies. Got questions? Of course you do. Stick around to get all the answers. Let's start with the basics. What exactly are black soldier fly larvae, and why are they so special? So, the black soldier fly? Not some action hero from a movie, but a small insect called Hermetia illucens, addresses 2 major challenges of our time: the feed shortage and the environmental crisis. Its larvae are tiny protein bombs. These creatures consume organic waste and turn it into high-quality feed for fish, poultry, and even pets. Larvae can process up to 110 tons of organic waste on just 2.5 acres of production space in a single month. What's more, they use 47% less water and produce 200 times less carbon dioxide than traditional livestock. EnviroFlight is one of the first companies to scale up this process. I visited their farm and saw firsthand how this ecosystem works. Imagine massive rooms filled with trays of larvae. Smelly? Sure, a bit, but it's more the smell of change, and I'm not exaggerating. The idea of using insects as a protein source didn't just come out of nowhere. It stemmed from global problems that have been brewing for decades: population growth, resource shortages, and the massive environmental toll of traditional livestock farming. But how did humanity come up with the idea of farming flies? People have been eating insects for thousands of years. In many parts of Africa, Asia, and Latin America, it's a normal thing. But until the 20th century, the concept of using insects as feed, instead of food for humans, was almost unheard of. Let's be honest, who would have thought, hey, let's raise flies to feed chickens? The first wave of interest in insects came in the 1960s. scientists started noticing that insects could be a protein source requiring minimal resources. But the idea didn't take off back then. People still relied on traditional methods: corn, soy, and fish meal. Then the modern environmental crisis emerged, forcing researchers to look for alternatives. The Hermetia illucens larvae became the star for a reason. Imagine this: the fly doesn't spread diseases, doesn't buzz around your house like a common housefly, and most importantly, its larvae can digest nearly any organic waste. It's the perfect little recycler. Interestingly, serious research into larvae started in the 1990s, and guess who funded it? Waste management companies. They were looking for ways to reduce the volume of organic waste ending up in landfills. It turned out that black soldier fly larvae could destroy up to 60% of organic material, converting it into protein and fats. That's when scientists thought, what if we used this for animal feed? Around the mid-2000s, the idea of insects as feed began gaining momentum. Picture startup founders in labs figuring out how to grow larvae on an industrial scale. They saw the growing demand for farmed fish and understood, if we don't find an alternative to fish meal, ocean ecosystems are doomed. The first successful projects appeared in Europe and the United States. One of the pioneers was EnviroFlight, which launched the concept of growing black soldier flies on organic waste. Their approach was simple yet brilliant. They created a closed-loop ecosystem where organic waste was transformed into feed, and leftover larvae were used as fertilizer. Let's talk about fish feed because this part really blew my mind. Did you know most fish feed is made from fish meal? Every year, over 15 million tons of wild fish are caught to produce feed for aquaculture. That's an enormous blow to marine ecosystems. Black soldier fly larvae provide an alternative that not only reduces dependence on fish meal, but also helps preserve oceanic fauna. For instance, 1 ton of larvae can replace over 2 tons of fish meal. That's equivalent to saving nearly 5 tons of wild fish. EnviroFlight raises larvae in controlled conditions where they feed on organic waste, leftovers from fruits, vegetables, or even coffee grounds. It's essentially a farm where the animals are tiny but incredibly productive larvae. They're fed, cared for, and when they reach a certain age, harvested, dried, and turned into feed. By the way, the entire process is designed to minimize environmental harm. From every 2 pounds of larvae, you can get over 10 ounces of high-protein feed. For comparison, raising pork requires about 13 pounds of feed to produce just 2 pounds of meat. Here, we've got a product that's several times more efficient than livestock farming. A lot of people are skeptical about the idea of feeding cats or dogs insects. But here's an interesting fact. According to a 2022 study, over 60% of pet owners in the United States are willing to buy pet food made from eco-friendly protein sources, including insects. Black soldier fly larvae have already been included in many premium pet foods. Their protein is not only nutritious, but also hypoallergenic. This is crucial for pets with sensitive stomachs or allergies to standard feeds. When I first heard the buzzing of these flies on the farm, I felt something strange. A bit unusual, a bit eerie, but mostly awe. This is the future we're building right now. I still think this process looks a bit futuristic, but if it's what will save our oceans, feed millions of pets, and make our planet better, I'm all in. How about you? Ready to support the idea of larvae in feed? It's good that humanity finally realizes how much traditional livestock farming drains the planet. For example, raising 1 cow costs the world more water and resources than an entire facility of larvae. People increasingly want to make eco-friendly choices, even in pet food. It's predicted that by the year 2050, Earth's population will grow to 10 billion. Finding new food sources isn't a luxury, it's a necessity. Does this kind of farming have a future? Let me answer that with another question. Does our planet have a future? Because if we don't switch to more sustainable food sources, we're in serious trouble. Right now, farms like EnviroFlight operate in over 30 countries, including the United States, the Netherlands, China, and South Africa. It's estimated that by the year 2030, the insect feed market will grow to $8 billion. Honestly, there's a certain irony to this. We spent hundreds of years trying to get rid of flies as pests, and now it turns out they might save our planet. Life loves surprises, doesn't it? From the outside, a farm like this looks like a cross between a factory and a greenhouse. The main building is modern, clean, and sterile. It's not a chaotic mess, but a high-tech space. The trays of larvae resemble multi-tiered shelves in a library, but instead of books, there are containers filled with wriggling larvae. Automation systems, robots and sensors, control everything from climate to the amount of food for the larvae. This farm isn't a chaotic swarm of flies and larvae. It's a structured system designed for maximum efficiency in farming and processing. It all starts in the fly room. This is a large space with special lighting and temperature control. Soldier flies buzz around in mesh containers or specially designed enclosures. They look pretty unremarkable, black, medium-sized, with long wings. The room maintains a warm, humid climate, perfect for breeding. The main goal here is to give the flies a place to lay eggs. Female flies deposit thousands of tiny eggs into special containers. These containers are wooden or plastic panels with small holes. The eggs are then moved to incubators, basically warm shelves, where temperature and humidity are kept optimal. Within a few days, tiny larvae hatch from the eggs. Next, we move to the larva rearing sector. Rows of trays or containers are filled with organic waste, leftover food, vegetable scraps, grain byproducts, and more. In these trays, larvae crawl around, growing at an incredible rate. They look like tiny, creamy worms that literally turn waste into protein mass. Automated systems for feeding and monitoring are often used here, with special sensors tracking temperature, humidity, and even the larvae's appetite. When the larvae reach the right size, they are harvested using specialized sieves or automated conveyors. Then they undergo processing. The larvae are dried at high temperatures or frozen to preserve nutrients. The dried larvae are ground into powder or pellets, which become the basis for feed. Besides protein, larvae are rich in healthy fats. These fats are extracted using presses and used in feed or for industrial purposes. In the finished goods warehouse, protein powder, fats, and other products derived from larvae are stored before being shipped to buyers. Did you know that over 2 billion cups of coffee are consumed every single day around the world? But how does your morning drink begin its journey from a tiny coffee cherry? Today, we're uncovering the secrets of instant coffee. From the first blossoms of coffee trees to the cutting-edge factories where beans transform into aromatic powder. Why is Arabica so delicate and Robusta so hardy? And how does production involve technologies that seem straight out of a sci-fi lab? Stick around. You'll be amazed by how many hands and minds it takes to create every jar of coffee. Before beans make it to the factory, they travel a long way, from small coffee plantations to industrial mills, and this journey starts long before the beans are ready to work. First, let's talk about Robusta and Arabica. They're like totally different personalities. They grow in different conditions, offer distinct flavors, and have unique growing demands. Fun fact: instant coffee usually uses Robusta, a bean known for its strength and high caffeine content. Arabica is also used, but less frequently, mainly in premium blends to add a smooth, sweeter flavor. Arabica is the premium bean. It's grown high up in the mountains, typically at elevations of 800 to 2,000 feet above sea level. It's picky. It loves mild climates, consistent rainfall, and temperatures between 60 and 75 degrees Fahrenheit. Robusta is less fussy. It thrives in lowlands, can handle heat, humidity, and even pests. Its ideal growing temperature can reach up to 86 degrees Fahrenheit. It's often cultivated in tough climates where Arabica wouldn't survive. Coffee plantations look like small forests. Coffee trees are grown from seeds, and get this, they take up to 3 years to bear their first fruit. Yep, 3 years before those cherries, which aren't even the coffee beans yet, but their outer shells appear. The trees are planted on specially prepared terraces, especially Arabica on slopes. The soil needs to be loose, rich in minerals, and moisture balanced. On many plantations, work is still done by hand, though some larger farms now use machines for planting. Coffee cherries take about 9 months to ripen after the trees bloom. And here's where the magic begins, timing the harvest just right. Handpicking is the best and most precise method. Workers pick only the ripe cherries, leaving the green ones to mature. It's labor-intensive, but guarantees quality, especially for Arabica. Robusta is often harvested with machines that comb cherries off the trees. It's faster and cheaper, but ripe and unripe cherries end up mixed. Handpicking Arabica ensures better quality, but requires a massive workforce. Entire villages or even seasonal workers from nearby regions often help on large plantations. Harvested cherries aren't beans yet, they're just the shells. To extract the coffee beans, cherries undergo processing. There are two main methods: wet processing and dry processing. Wet processing is mostly used for Arabica. Cherries are soaked in water, where the pulp dissolves and the beans separate. It's pricier, but results in a clean, delicate flavor. Dry processing is more common for Robusta. Cherries are simply spread out to dry under the sun, and then the shells are removed. It's cheaper, but creates a bolder, more intense taste. After processing, the beans are sorted by size, weight, and quality. The best beans go into premium coffee products, while smaller or slightly damaged ones are used for more budget-friendly options or instant coffee. Here's something cool I learned. Robusta beans are usually round and tougher, while Arabica beans are oval and a bit softer to the touch. Once beans are ready, they're packed in classic jute bags. Why jute? It lets the beans breathe during transportation. On plantations, these bags are often loaded onto small trucks or even motorcycles to reach nearby ports or warehouses. Then, the beans are shipped in large containers that can carry hundreds of tons of coffee at a time. Beans often pass through several countries before reaching the factory. For example, coffee might be grown in Vietnam, one of the world's largest Robusta producers, processed in another country, and roasted or turned into instant coffee at a factory in Europe or the US. Before beans are transformed into instant coffee, they're checked for quality multiple times. On plantations, defective cherries are removed before processing. Before shipping, beans undergo another round of checks at warehouses and ports. This includes examining size, color, and aroma. At the factory, samples from each batch are tasted to ensure the flavor meets standards. Everything starts with coffee beans. At the factory I visited, roasted beans are delivered, and their smell, wow! It's that rich aroma you get when you walk into a coffee shop. Fun fact, roasting follows an incredibly precise schedule. Every second impacts the final flavor. So, where does roasting happen? At roasting facilities. Roasting is a whole universe of its own. It significantly affects coffee's taste and aroma, so it's taken seriously. There are several ways this can go down. Sometimes, especially for large Robusta volumes, beans are roasted in their country of origin, like Vietnam or Brazil. These countries have massive export-focused factories, which cut down on logistics costs. Big brands have their own roasting facilities in key regions. For example, in Europe or the US, there are giant factories specializing exclusively in roasting. Roasting beans separately isn't just a preference, it's logical. Green coffee beans are easier to transport long distances because they're less sensitive to storage conditions. Specialized facilities ensure a consistent roast level needed for specific products. Plus, depending on the end use, instant coffee or ground coffee, beans are roasted differently. Roasting coffee is a science. Beans are heated in rotating drums at temperatures around 400 degrees Fahrenheit. The roast time depends on the desired profile, lighter for softer flavors, darker for bold, intense notes. Instant coffee typically uses dark roasts. This enhances aroma and adds a bitterness that holds up even after processing. Roasted beans are cooled and packed to preserve their aroma. The factory receives this semi-finished product and focuses on its processes. It's a bit like a chef starting with a ready-made base to create a masterpiece. The first step after delivery is grinding the beans to a dust-like consistency. No, this isn't your regular grind for a French press or espresso. Industrial mills turn beans into particles finer than sand grains. Why so fine? I asked one of the staff. The answer was simple. The smaller the particles, the more efficiently the flavor and aroma are extracted in the next steps. Here's where the real chemistry begins. The ground powder goes into special extraction chambers, where it's brewed with hot water under pressure. Think of it as a giant coffee maker. This is where all the flavor and aroma you enjoy in your instant coffee are drawn out. What surprised me? The water temperature is controlled to the exact degree to avoid overbrewing. If it's too hot, the taste becomes bitter, too cool, and the coffee loses its richness. The extract from these chambers undergoes multi-stage filtration. All unwanted particles are removed, leaving only a liquid concentrate. This concentrate looks like thick syrup and has such a strong aroma, it'll make your head spin. Next comes the most fascinating part. The liquid concentrate is turned into powder or granules using two main methods: spray drying or freeze drying. Spray drying involves blasting hot air to dry droplets of concentrate, leaving behind dry powder. It's fast and relatively cheap, but sometimes loses some aroma. Freeze drying is more complex. The concentrate is first frozen to extremely low temperatures, then sublimated, turning ice into vapor and leaving dry granules behind. It's pricier, but preserves maximum flavor. At the factory I visited, both methods were used depending on the coffee type. For premium lines, only freeze drying was used. The finished powder or granules are packed into jars, sachets, or sticks. It's all automated. Machines measure exact amounts, seal the packages, and add protective valves to preserve aroma. By the way, these valves are a real technological breakthrough. They let air out of the jar, but don't let it back in. You might wonder, how do they keep the aroma? The secret is that some of the coffee oils and aromatic compounds lost during extraction are collected separately and added back to the final product. It's like a little bonus that makes instant coffee so familiar and fragrant. Is instant coffee real coffee? You know, I was a bit skeptical myself until I saw the whole process. It really is 100% coffee, just with a touch of engineering magic. Actually, scratch that, it's more like technical mastery. The difference between instant coffee and freshly brewed coffee is like the difference between homemade pizza and takeout pizza. They're both great, but in different ways. Instant coffee is quicker, more convenient, and still incredibly flavorful when done right. After the tour, I was blown away by how intricate and well thought out the process is. And you know what amazed me the most? The sheer number of people involved, from engineers monitoring the equipment to tasters checking every batch. Yes, tasters. Turns out it's a real profession. Imagine having a job where you drink coffee and evaluate its taste. Isn't that the dream? Instant coffee isn't just powder in a jar. It's a monumental effort, cutting-edge technology, and a love for a drink that brings us comfort, even on the busiest days. So, next time you make yourself a cup, remember the many hands that work to deliver that aroma to you. One factory, 1 million chickens, over 500,000 eggs every single day, and roughly 120 tons of feed. Imagine that. Automated systems handle feeding, sorting, and packaging to keep this process running non-stop. Every day, these chickens drink enough water to fill 29 Olympic-sized swimming pools. Modern tech makes it possible for a chicken metropolis to run with just about 100 workers. How is that even possible? You'll find out in our video. Chickens on large farms are kept either in cages or in free-range systems. If they're in cages, these are arranged in multi-level rows. Think of it like a chicken skyscraper. Each cage has everything a chicken needs: perches, feeders, drinkers, and even a sloped floor so eggs roll straight into a collection tray after being laid. On the other hand, free-range chickens have more space to roam. They get access to the outdoors, though it's usually not a lush green field, but specially designed enclosed areas. Even in these systems, everything is organized down to the smallest detail. This factory houses 1 million chickens in a caged system, covering over 25 acres. By comparison, the same number of birds in a free-range system would need more than 80 acres. Here's another fascinating fact. Modern farms maximize vertical space, especially in caged systems, to optimize efficiency. Most of the area is used for multi-level production facilities, housing cages, feed silos, sorting rooms, and staff areas. The chickens are fed specially formulated feed to ensure consistent egg production. This feed is a mix of grains, corn, soybeans, and added vitamins and minerals. And here's the kicker. Every single gram of feed is crucial because it determines the quality and quantity of the eggs. Feed is constantly tested for protein, calcium, and potential contaminants. Some farms even add herbal extracts to keep the chickens healthy without antibiotics. Large farms use automated feeding systems. Feed is distributed through pipes or conveyor belts, filling feeders in the cages or barns. Sensors monitor feed levels and automatically dispense more when needed. Chickens receive feed tailored to their stage of life. Young chicks get starter feed rich in protein and energy. Layers receive feed high in calcium, vitamins, and trace minerals for strong eggshells. Chickens nearing the end of their life cycle get finisher feed. The feed also includes additives to support digestive health, boost immunity, and improve egg quality. Chickens are fed 2 to 4 times daily, depending on the system. Some farms schedule feedings right before laying time to encourage consistent egg production. Layers consume about 5 ounces of feed daily. For 1 million chickens, that's nearly 120 tons of feed every day, or about 40,000 tons annually. Just look at the massive silos and transportation systems needed to manage that volume. In addition to feed, chickens are provided with clean drinking water. Nipple drinkers allow them to drink without spilling. 1 million chickens require over 2.5 million gallons of water annually, roughly the amount held by 29 Olympic-sized swimming pools. Feed is stored in silos, protected from moisture and mold. Its nutritional content is constantly analyzed to ensure quality. Modern farms even use software to track how much feed each group of chickens consumes. In some free-range systems, chickens are also allowed to forage for grass, insects, and grains, making their diet more natural. But even here, the primary feed is delivered automatically. Feeding systems are key to ensuring chickens lay eggs consistently and stay healthy throughout their production cycle. After laying, eggs roll into trays through special chutes. From there, they're transported on conveyor belts. Imagine an endless line of eggs floating towards sorting machines. These machines check for defects, discarding damaged or undersized eggs using special scanners that literally illuminate the eggs. It's futuristic. Before packaging, eggs are carefully washed in warm water with gentle disinfectants. This step ensures their safety. And no, it's not just a quick rinse. Eggs go through several warm water baths to remove dirt and microorganisms. Then they're dried and coated with a thin layer of food-grade wax for protection. At the sorting stage, each egg is weighed and categorized: large, medium, and so on. Depending on the category, eggs are packed into boxes. Simultaneously, shells are dried to prevent moisture that could lead to bacterial growth. Clean inspected eggs are placed in cartons or plastic trays by automated arms. Packaging includes details like packing date, grade, size, and producer certification. Storing such a daily volume of eggs requires refrigerators with over 70,000 cubic feet of capacity, about 40 large refrigerated trucks. After packaging, eggs are sent to storage facilities or logistics centers. Here, strict temperature controls between 32 and 40 degrees Fahrenheit keep them fresh. Eggs are transported in refrigerated trucks to prevent spoilage. At distribution centers, eggs are sorted based on supermarket orders and quickly delivered to stores or markets. Modern logistics systems reduce the time from farm to shelf to just a few days. Once on supermarket shelves, eggs are stored in refrigerators to maintain freshness. Consistent storage temperatures are crucial because sudden changes can cause condensation, increasing the risk of shell contamination. Consumers choose eggs based on size, price, brand, or labels like organic or free range. At home, eggs are stored in the fridge. Freshness is easy to check. If an egg sinks in water, it's good to use. Although large-scale farms are resource-intensive, many are adopting eco-friendly initiatives. These efforts not only reduce environmental impact, but also meet growing consumer demand for sustainable products. Some farms invest in solar panels on facility roofs or nearby solar fields, covering 30 to 50% of their energy needs. Chicken manure, a natural byproduct of any farm, is a valuable resource for agriculture. Chickens produce as much manure as the feed they consume, over 100 tons daily. Manure is collected, dried, and processed into organic fertilizer. Instead of creating waste, farms provide a product that restores soil fertility and reduces reliance on chemical fertilizers. Fertilizer production from chicken manure also lowers methane emissions compared to natural decomposition. Did you know a single chicken lays 1 egg a day? Of course, 1,000,000 chickens don't equal 1,000,000 eggs daily, since some aren't laying yet or have stopped laying. Still, production numbers are impressive, over 500,000 eggs each day. Stack those eggs, and you'd get a column over 29,500 feet tall, 23 times higher than the orbit of the International Space Station. Younger chickens lay eggs almost daily, while older ones do so less frequently. Balanced feed helps boost egg production. Factors like temperature, lighting, and stress-free conditions also play a big role. During winter, shorter daylight hours can slightly reduce laying rates. American eggs are rich in protein, vitamins D and B12, iron, and other nutrients. There are even eggs with higher omega-3 content, depending on the chicken's diet. You know what surprised me the most? The small workforce. Modern automation allows a 1,000,000 chicken farm to operate with just 100 or so workers. Their tasks include equipment monitoring, veterinary care, and managing feed and egg logistics. A farm of this size can generate up to $50 million in annual revenue. This makes a significant contribution to the local economy, especially in logistics, feed production, and processing. These numbers show just how massive and coordinated the effort is to keep a steady flow of eggs heading to stores and ultimately to our kitchens. Have you ever wondered how many times aluminum can be recycled? Imagine this. 1 can you drank from today could be back on the shelf as a brand new can in just 60 days. And here's a jaw-dropper. Over 120,000 aluminum cans are used every minute worldwide. But wait, there's more. In the United States alone, enough cans are recycled each year to cover 3,000 football fields. Why is recycling aluminum so critical? How do these tiny metal heroes make such a massive impact on the planet? Let's dive into this video where every statistic amazes, and the transformation process will leave you inspired. The journey of recycling aluminum cans starts with collection, a crucial step in the recycling chain because timely gathering of raw materials ensures efficient processing later on. Most aluminum cans are collected through specialized waste collection systems in cities and communities. Many countries have waste sorting programs encouraging consumers to deposit empty cans in dedicated metal recycling bins. In the United States, there are widespread redemption centers where consumers can return used cans for a small cash reward or discount, incentivizing eco-friendly behavior. These programs are also common in parts of Europe and Australia. Some regions even organize campaigns where individuals can bring used cans to special recycling stations, making it easier to gather metal waste while reducing environmental pollution. Globally, about 120,000 aluminum cans are used every single minute, a staggering number that highlights the importance of efficient recycling. Many stores feature special bins for collecting empty aluminum cans, especially in areas with popular deposit systems where consumers can return packaging for a refund, often earning a few cents for each can. Beverage manufacturers and packaging companies also participate in the recycling process by sending metal waste from production to collection centers. This applies to used cans and leftover aluminum elements from the manufacturing process. Some recycling systems even include automatic waste sorting at the collection stage. Advanced technologies like magnetic separators are used to extract aluminum from other metals and plastics efficiently. In regions without such systems, manual sorting is still the norm. In the United States, the aluminum can recycling market is valued at over $1 billion annually. This massive industry injects revenue back into the economy, fueling businesses that recycle and produce new products from repurposed metal. Once collected and sorted, the cans are transported to a recycling facility, where they're stored in massive containers or warehouses until processing begins. The entire recycling journey of an aluminum can take less than 60 days, from the moment it arrives at the facility to the moment it's transformed into a brand new product. That means the can you finished today could be back on the shelf in just 2 months. To ensure a smooth process, cans must be kept separate from other waste materials, so they're often stored separately. Before moving on to further processing, the cans undergo a thorough cleaning. This includes washing off any leftover liquids, removing labels, adhesives, and other contaminants that might still be on the packaging. And now for the most epic part, shredding. Once cleaned, the cans are shredded into small pieces using industrial shredders or other mechanical equipment. This step drastically reduces the volume of the material, making it easier to process. What's left are aluminum shreds or chunks, ready to be transformed into new products. I've got to say, being there for this part was nerve-wracking. It felt like one of those shards might fly off and hit me in the eye. And the noise, the grinding and crunching were absolutely deafening. Hot. Insanely, blisteringly hot. That's how it felt when we approached the smelting furnace. The shredded aluminum pieces are sent straight into it. 1,220 degrees Fahrenheit, a temperature so intense, it's surprising it's not 1,222 for some devilish symmetry. Melting is the key stage where the metal is heated until it turns liquid. During this process, any remaining impurities and other materials are burned away, leaving behind pure aluminum ready for reuse. Watching it felt like witnessing the Terminator's final moments. I swear. The team explained to me that smelting is energy intensive, but even with the high energy consumption, this process is far more efficient and less costly than extracting virgin aluminum from ore. The molten aluminum from the furnace is poured into molds to create ingots, wire rods, or sheet metal. These aluminum ingots, known as slabs, are massive blocks that are easy to handle during later processing stages. Each slab measures several yards in length and about 2 feet thick. Once cooled and solidified, this metal is ready for a new life, whether as fresh aluminum cans, car parts, construction materials, or other products. Here's the incredible part. This process can be repeated endlessly. Aluminum can be recycled over and over without losing its quality. Imagine that. Cans can go through the recycling loop dozens, even hundreds of times. It doesn't wear out from remelting. Honestly, it feels like we were lied to. Terminator had to be made of aluminum, folks. Now, what are these wire rods, you ask? Fair question, and I've got the answer for you. Wire rods are a form of aluminum created after the molten metal is poured and shaped into thin wires or rods. After smelting, the liquid aluminum is cast into molds for further processing. The metal is rolled into large wire rods using specialized rolling mills. These mills reduce the cross-section of the metal and shape it into the desired form by passing it through rollers. The rods can then be cut into smaller sections or sent off for additional processing to create a variety of aluminum products. In the end, wire rods are the foundational form of aluminum used to manufacture new products. This keeps the recycling and reuse cycle going strong. The diameter of aluminum rods can vary depending on their intended purpose, typically ranging from 4/100ths of an inch to 3/4 of an inch. However, this can change based on production specifications and the final application. Thin wire rods, with a diameter ranging from 4/100ths to 1/10 of an inch, are commonly used to make wires, electrical cables, or delicate metal components. Medium wire rods, measuring 1/1600ths to 4/10ths of an inch, are suitable for sturdier products like structural elements, or, in some cases, new aluminum cans, when further processing requires that specific diameter. Thick wire rods, over 4/10ths of an inch in diameter, are reserved for heavy-duty applications such as the automotive industry or the production of large structural components. Each type of wire rod has its own specifications and undergoes additional processing depending on the final aluminum product being manufactured. To produce aluminum sheets, the slabs are gently heated and passed through powerful rolling mills that flatten them into thin sheets. At this stage, the sheets measure about 1/4 to 2/5 of an inch thick, but they're still too thick for most applications. After hot rolling, the sheets are cooled to stabilize their structure. If needed, they undergo annealing. a controlled process of heating and slow cooling, to relieve internal stress and improve the metal's flexibility. For ultra-thin sheets, like foil or packaging materials, the aluminum goes through cold rolling, reducing its thickness to less than 0.04 of an inch. This precision ensures the sheets meet the requirements for various specialized applications. Once the aluminum is formed into the required shape, whether as wire rods or sheets, it's transported to factories or directly to customers for further use in manufacturing. Recycling aluminum requires significantly less energy compared to extracting new material from ore. In fact, recycling aluminum saves up to 95% of the energy that would otherwise be needed for mining and processing raw aluminum. To put it into perspective, it's like a 100-watt light bulb running for 4 hours. Here's another mind-blowing stat. If all the aluminum cans recycled in the United States each year were stacked end to end, they'd cover approximately 3,000 football fields. And if you combined the recycled cans from the US and Europe, they could wrap around the Earth twice. How did a small pharmacy in Switzerland grow into an empire that gifted the world legendary flavors? Today, we're diving into the story of Nestlé, from saving infant lives to creating iconic products that captured millions of hearts. You'll uncover shocking facts about Kit Kat, the revolutionary Nespresso capsules, and the secrets of success that took the company to the top. Stick around until the end to learn more. Switzerland, the 1860s. Can you picture the world back then? The Industrial Revolution was in full swing, technology was advancing, yet everyday life faced serious challenges. One of the biggest issues? Infant mortality. A lack of quality infant nutrition was proving fatal for many newborns. In a small Swiss town called Vevey, a pharmacist named Henri Nestlé was hard at work. Henri wasn't just skilled in chemistry, he had an intense drive to create something meaningful for society. His breakthrough came in 1867 when he developed a milk-based formula called farine lactée, a blend of milk, wheat flour, and sugar. Designed for infants unable to breastfeed, it shocked the world by actually working. Henri chose a logo that remains unchanged to this day, a nest with baby birds. It symbolizes care, family warmth, and safety. Fun fact, the word Nestlé means little nest in German. How's that for a fitting metaphor? After the success of farine lactée, the company rapidly expanded its product range. One hit followed another: chocolate, condensed milk, infant nutrition. By 1905, Nestlé merged with the Anglo-Swiss Condensed Milk Company, a major step toward globalization. In the 1920s, Nestlé entered markets in the United States, Australia, Asia, and Africa. Then, in 1938, Nescafé was born, a game-changer in the coffee world. Did you know that this product was developed at the request of the Brazilian government to find a way to preserve surplus coffee beans? Just 9 years later, Nestlé joined forces with Maggi, and that's how the story of their famous soup cubes began. And this is just the beginning. When you hear Nestlé, what's the first thing that comes to mind? Maybe it's Kit Kat chocolate or Nescafé coffee? The truth is, this company covers a massive range of categories. Chocolate and snacks? Think Kit Kat, Smarties, Aero. Coffee? Nescafé, Nespresso, Starbucks. Yes, Nestlé holds the license to produce Starbucks coffee. Ice cream? Häagen-Dazs and Mövenpick. Baby food? Nan and Gerber. Pet products? Purina, Felix, Friskies. Quick meals? Maggi and Nesquik. Water? San Pellegrino and Perrier. So, what do you always buy from this list? Nestlé tailors its products to local tastes. For example, in India, Maggi is popular with curry spices. In Japan, Kit Kat comes in dozens of flavors, from wasabi to sakura. Their chocolate adapts to each market. Kit Kat in the United Kingdom has a softer taste than in the United States. Meanwhile, in Latin America, people love the sweet condensed milk La Lechera, which is a staple in desserts. Nestlé's production is a blend of science, technology, and art. The company's factories span over 80 countries worldwide, each using unique technologies. Many iconic products have been born under this brand. Take Nespresso, Nestlé spent years on research to create it. Their engineers even developed a special capsule sealing technology to lock in the coffee's aroma. Let's take a closer look at how it all happened. In the 1970s, Nestlé engineer Eric Favre was working on an idea that would revolutionize how we enjoy coffee at home. Eric drew inspiration from classic Italian espresso bars. His wife, an Italian, had a deep love for authentic espresso, and it was her passion that sparked his curiosity. Eric noticed that in many Italian coffee shops, baristas would introduce extra air into the machine before extraction to create the perfect crema, that creamy foam that signifies great coffee. And then it hit him. Why not make coffee like this accessible to everyone, right at home? That's how the idea for the capsule system was born. A system that locks in flavor, is easy to use, and delivers consistent quality every time. The first attempts to create coffee in capsules were anything but easy. The challenge wasn't just about sealing ground coffee in an airtight capsule. It was about making that capsule work seamlessly with a machine capable of delivering the precise water pressure. Here's the tricky part. Coffee aromas are highly volatile. To preserve freshness, the capsule had to be perfectly airtight. Engineers needed a material that could withstand high pressure and temperature without altering the coffee's flavor. And let's not forget, creating the perfect espresso requires a pressure of 19 bars, a tough feat to achieve in a compact machine for home use. In the end, Nestlé developed aluminum capsules. These not only protect coffee from oxygen, but also ensure the correct pressure during brewing. When the capsule is inserted into the machine, it gets punctured, allowing water under high pressure to pass through. This extracts a rich flavor and creates that signature creamy foam. Here's another innovation. The engineers designed a special vacuum sealing mechanism to keep the capsules fresh for months. The combination of vacuum technology and the aluminum casing turned out to be perfect. Interestingly, Nespresso wasn't an instant hit. When it launched in 1986, the product was initially targeted at offices and business clients. It wasn't until a few years later, when the marketing team shifted focus to the premium home market, that its popularity began to soar. Think about it. The sleek machine designs, sophisticated ad campaigns, and the iconic "What else?" tagline delivered by George Clooney. All of this played a huge role in turning Nespresso into a symbol of style and quality. The patent for Nespresso's capsule technology was once at the center of major legal battles. When the patent expired, competitors began creating capsules compatible with Nespresso machines. Yet, Nestlé still holds the lead, thanks to continuous innovation and its premium branding. Here's a jaw-dropping stat. Around 14 Nespresso capsules are sold every second worldwide. Every year, Nestlé invests millions of dollars into improving coffee technologies. On top of that, the brand runs 90,000 recycling points for capsules as part of its commitment to sustainability. Every day, over 1 billion products are manufactured in Nestlé factories. The company employs 270,000 people and operates 447 factories across the globe. Let's take a closer look at some of Nestlé's most popular products. Nescafé, the legend of instant coffee. This might just be Nestlé's most iconic product, sold in over 180 countries. The name itself has become synonymous with instant coffee. The brand has been around since 1938, when Nestlé introduced the first instant coffee for convenient at-home brewing. Here's a fun fact. Over 6,000 cups of Nescafé are consumed every second worldwide. Plus, Nescafé adapts to regional preferences. In Latin America, sweeter blends are a hit. In Asia, milkier versions are popular. And in Europe, classic black coffee is the go-to choice. Kit Kat, one of the world's most beloved chocolate bars. First introduced in the United Kingdom in 1935, its popularity skyrocketed after Nestlé acquired the brand. In more than 80 countries, people say, "Have a break? Have a Kit Kat." In the baby food segment, Gerber is the undisputed leader. Acquired by Nestlé in 2007, Gerber is now synonymous with high-quality nutrition for infants. It's sold in over 70 countries and is a favorite among young parents thanks to rigorous quality standards. Each product undergoes over 100 quality checks. Maggi, soups, spices, and noodles, holds immense popularity across Asia, Africa, and Europe. Nestlé Pure Life, one of the most popular bottled water brands in the world. Smarties, these colorful candies, are loved by kids and adults all over Europe. Here's a fun fact. Nestlé, in collaboration with Daniel Peter, created the world's first milk chocolate back in 1875. It was revolutionary at the time, and today, Nestlé remains one of the largest chocolate producers in the world. Whether it's coffee or chocolate, Nestlé knows how to create products that win over millions of hearts. What's your favorite? Nestlé isn't slowing down. The company is heavily investing in plant-based alternatives, personalized nutrition, and eco-friendly projects. For instance, in Switzerland, they're already testing a new sugar-free chocolate sweetened with natural cocoa fibers. Nestlé is also working hard to reduce plastic use, aiming to make all their packaging recyclable. And here's the kicker. They're developing products tailored to individual body needs, using DNA-based nutrition. From your morning coffee to a quick Kit Kat break, this brand is practically everywhere. Isn't that the ultimate mark of success? Nestlé is a story of innovation, care, and the courage to do things differently. So, the next time you enjoy one of their products, remember, behind it lies over 150 years of dedication, dreams, and love for what they do. The secret to Nestlé's success lies in many factors. This is a company that doesn't just sell products. It creates a lifestyle, adapting to the needs and expectations of people around the world. Nestlé has always prioritized innovation, consistently investing in science and research. With over 20 research and development centers globally, their engineers, biologists, and chemists work tirelessly to develop products that align with modern trends. Less sugar, more nutrition, and convenient packaging. Nestlé operates with a clear philosophy: think globally, act locally. This strategy helps them stay close to consumers and create products that feel personally crafted for them. And let's not forget, Nestlé are marketing masters. They don't just advertise products, they build emotional connections with their customers. They're also quick to embrace modern platforms, from TikTok to Instagram, staying in sync with their audience. Ever wondered where piles of old newspapers and boxes disappear? Every day, recycling centers process thousands of tons of paper waste, sorting it in seconds and transforming it into fresh sheets. Picture this: massive hangars, conveyor lines as long as a football field, sorting machines equipped with optical sensors, and drying cylinders heated to 260 degrees Fahrenheit. In just 5 to 7 cycles, paper fibers are reborn, becoming packaging, notebooks, or even furniture. Let's dive into the secrets of paper transformation. Think old newspapers or cardboard boxes are just trash? Think again. They have a future. It all starts simply. Paper and cardboard are collected. That includes old magazines, packing boxes, and even crumpled receipts. From there, the sorting begins, dividing materials by type and quality. For instance, cardboard is denser, while office paper is thin and clean. Sorting is a crucial step in giving paper a second life. So, let's break it down, step by step, in vivid detail. First, meet the key players in the process: machines and people. At large recycling centers, automated sorting lines handle the bulk of the work. But human hands are still essential. Operators on conveyor belts carefully check the paper's quality. It's a teamwork scenario where machines do the heavy lifting, and people fine-tune the details. Recycling centers often look like giant hangars filled with mountains of raw material. Stacks of old newspapers, cardboard boxes, office documents, and even postcards. Here, conveyors roar and automated sorting systems buzz, processing everything. Here's how it works, step by step. First up, the initial inspection. Once collected, garbage trucks or special vehicles deliver the paper to the sorting center. At this stage, large contaminants like plastic wrappers, fabric scraps, or glossy-coated materials are removed by hand. Next, the automated machines take over, sorting paper by type and quality. Types include cardboard, newspapers, office paper, glossy paper, and packaging. Quality-wise, it's about separating clean paper from dirty, like sheets with grease stains or adhesive residue, which can't be recycled. Optical sensors and air filters play a big role here. Sensors scan the paper, while compressed air streams direct materials into their respective categories. Cardboard goes left, newspapers go right. Even the best machines make mistakes, right? That's where human operators step in to remove leftover foreign objects, like tape, staples, or plastic windows from envelopes. This process moves fast and demands sharp attention. After sorting, the paper is compacted into massive bales for easier transport to factories. Imagine blocks the size of a refrigerator, neatly packed and ready for a new life. Fun fact, old newspapers are easier to recycle than glossy magazines. Why? The glossy coating is harder to remove. Office paper, being high quality, often gets turned into new sheets for printing or even toilet paper. Next comes shredding and cleaning, the phase where old paper becomes the base for new material. Think of it as a paper bath, with powerful machines that not only shred, but also meticulously clean the paper of any impurities. Let's dive into the details. Compressed paper bales go into hydropulpers. Sounds intense, but these are just giant mixers. The paper is soaked in large amounts of warm water to help separate the fibers. Why water? It softens the paper, breaking it down into its cellulose fibers. Special chemicals, safe for the environment, are often added, like soap or alkaline solutions, to remove ink and glue. The hydropulpers kick into action, spinning water and paper at high speeds. The result? The paper breaks down into microscopic fibers, turning into pulp. Yes, that's the term. A gray, wet, slurry-like mass. At this stage, old boxes, newspapers, and letters lose their form and start a new cycle of life. The next step is cleaning the pulp to remove contaminants like plastic, glue, staples, and ink. It starts with screens of varying sizes. The pulp is pushed through under pressure, leaving larger debris like tape, staples, plastic bits, or thread behind. Smaller particles continue downstream. Then come the centrifuges. Remember physics class? In a centrifuge, everything spins, and heavier particles like sand or metal sink to the bottom, while lighter materials like plastic films rise to the top for separate removal. Water and centrifugal force work together, a perfect team. For ink removal, a process called de-inking is used. Foam made from soap and chemicals is added to the pulp. As the mixture spins, bubbles lift the ink to the surface, creating a frothy layer that carries the ink away. This method, called flotation, works like separating oil from water. Only here, it's ink instead of oil. Finally, the pulp is rinsed with clean water to remove any leftover chemicals or impurities, leaving a clean, fibrous mass ready for the next step, forming new paper. Let me know if you'd like further refinement or adjustments to the style. Glue, especially from labels or packaging, can be a real nuisance. During the cleaning process, it forms sticky clumps. To deal with this, special machines called tack removers capture those clumps before they ruin the final material. At this stage, the pulp is clean, light gray, or almost white, ready for the next step, forming new paper or cardboard. Old newspapers and boxes transform into material that can become packaging, napkins, or even part of furniture. Here's something fascinating. Paper can go through this recycling cycle 5 to 7 times before the fibers become too short for further processing. But until then, hooray, the paper's life continues. From the cleaned pulp, new sheets of paper or cardboard are created. The pulp is pressed, dried, and voila, a new product appears, the packaging for your favorite smoothie or a sleek notebook for your ideas. First, the pulp is spread into a thin, watery layer. It's poured onto a massive moving conveyor covered with a fine mesh, a sort of endless cloth that keeps moving. Water starts draining, and the pulp gradually thickens. This is where pressure takes the stage, turning the process into a true display of technical mastery. The first press, called the forming press, provides a gentle squeeze. Rollers press the pulp onto the moving mesh, evening out the thickness. These rollers are set at varying heights and pressures to make the pulp uniform. At this point, the pulp loses about half its water. Simply put, it goes from a watery mass to something resembling damp felt. Not yet paper, but with a clear structure. Next, the sheet moves to the second press, known as the smoothing press. Here, the pressure increases significantly. Heated rollers squeeze out the remaining water, speeding up the drying process. Not only does the paper or cardboard become thinner, but it also gains strength. At this stage, texture can be added. For instance, office paper gets a smooth finish, while packaging cardboard might have a more textured surface. This is achieved using rollers with patterned surfaces. After pressing, the sheet passes through a series of drying cylinders, massive metal drums heated from the inside. These cylinders reach temperatures of 260 degrees Fahrenheit, and the sheet glides over their surface. Moisture evaporates, leaving the paper or cardboard dry and strong. The cylinders press the sheet tightly against their hot surfaces, ensuring even and quick drying. Alongside the heat, hot air blowers are used to prevent uneven drying. After all, the paper needs to be consistently dry across its entire surface. During drying, the thickness of the final product can be controlled. For example, to make thin paper for notebooks or thick cardboard for boxes, adjustments are made to the roller pressure and the number of passes through the drying cylinders. Before the final drying stage, a special coating can be applied to the sheet, for instance, to give it a glossy finish. These coatings might include starch mixtures to strengthen the paper or clay solutions for added shine. The coating is applied in a smooth layer using yet another roller. After drying, the sheet becomes a finished product. But it doesn't end there. It can be rolled into giant reels if it's destined for printing houses or factories. Alternatively, it can be cut into individual sheets like office paper. Here's a cool fact. One of the main goals of this entire process is to preserve the cellulose fiber's properties as much as possible. These fibers give paper its strength and flexibility. In a way, each sheet is the result of a symphony of machines and human ingenuity. Recycled paper becomes the foundation for thousands of new products. In the packaging industry, it's used for delivery boxes, shopping bags, and disposable cups. It can even turn into furniture or decor, creative cardboard chairs, lamps, or even bookshelves. These items are stylish and can last for years. Most commonly, paper is recycled into stationery, notebooks, folders, and even paper pens. Recycled paper is also ideal for creative projects like greeting cards, scrapbooks, or home decorations. It's amazing to think how an ordinary newspaper or box can live a brand new life. Instead of ending up in a landfill, it gets a second chance to become something useful. Here we are, standing at the entrance of a massive cornflakes factory. Did you know that around 4 billion pounds of cornflakes are made worldwide every year? Impressive, right? You ready? Let's go. I'll walk you through everything step by step, from the very beginning all the way to how these crunchy, delicious flakes end up on your breakfast table. It all starts in the cornfields. For cornflakes, a specific type of corn is used, yellow dent corn. This variety isn't like the sweet corn we're used to eating boiled or grilled. It's starchier and contains less sugar, making it perfect for processing. The corn is harvested using massive combines that literally slice through the fields, stripping the cobs and separating the kernels. From there, it's sent to the factory. Before transportation, the corn is carefully dried to reduce moisture and preserve its quality during transit. At the factory, the kernels undergo hundreds of tests. They're checked for size, density, moisture levels, and even color. Every detail matters to create perfectly uniform and crispy flakes. And when it comes to cornflakes, the most iconic brand is still Kellogg's, which first introduced them way back in 1894. Cornflakes, like many culinary inventions, were born out of a mix of chance and experimentation. They were created by the Kellogg brothers, John Harvey Kellogg and his younger brother, Will Keith Kellogg, in the late 19th century. John Harvey Kellogg was a doctor and the director of a sanitarium in Battle Creek, Michigan, USA. His sanitarium followed strict principles of healthy living, offering patients a plant-based diet, physical exercise, and even some rather radical treatments, like hydrotherapy. One of John's main goals was to develop healthy and easy-to-digest food for his patients. Will Keith Kellogg, his brother, worked alongside him at the sanitarium, handling administrative tasks and helping bring his ideas to life. In 1894, John and Will were experimenting with different ways to process grains to make them easier to digest. One day, they cooked a batch of wheat dough, but accidentally left it out to dry for too long. By the time they returned, the dough had become overly dry and brittle. Curious, they decided to run it through rollers to see what would happen. To their surprise, the result was thin flakes, which they toasted to make crispy. The patients at the sanitarium loved them. Later, the brothers decided to try experimenting with corn, as it was cheaper, more widely available, and delivered even better results. And just like that, cornflakes were born. After the success of their flakes, Will Keith Kellogg saw massive business potential and wanted to sell them on a larger scale. However, John Harvey Kellogg disagreed. He viewed them solely as dietary food for patients. In 1906, Will founded the Kellogg's Company, which remains the world's largest producer of cornflakes to this day. The production scale has grown so much that Kellogg's now uses over 1.5 billion pounds of corn every year. Cornflakes became a massive hit in the US, especially among women who loved them as a quick and easy breakfast option. The original recipe was simple, just corn, salt, and a little sugar. Today's versions come in dozens of flavors and include all kinds of additional ingredients. Now here we are inside the production floor. Huge silos are filled with corn, which is gradually fed into the first stage, cleaning. Specialized machines remove debris, stones, leftover cobs, and husks. Next, the corn goes through a magnetic separator. You might be wondering, why a magnet? It's to ensure no metal fragments from harvesting or transport make it through. Once the corn is thoroughly cleaned, it's sent to giant tanks filled with hot water. Here, it cooks for several hours at around 212 degrees Fahrenheit. This softens the kernels and allows them to absorb moisture, preparing them for the next stages of processing. After boiling, the corn is moved into machines that separate the germ and the hull from the kernel. The germ, the part of the grain that's packed with oil, is removed so the flakes don't turn out too greasy. Once the kernel is cleaned, it's ready for the next step, roller processing. And here's where things get really exciting. The cleaned corn kernels are poured into specialized steel rollers that, under immense pressure, flatten each kernel into a thin sheet. These rollers spin at incredible speeds, and the entire process happens almost instantly. Watching it in real time feels like magic. Corn literally transforms into flakes right before your eyes. The flattened kernels now resemble thin, golden discs. But hold on, they're not quite the flakes you're used to eating just yet. Now we're getting to the massive ovens. This is where the flakes are dried and toasted at around 482 degrees Fahrenheit. It's here that they develop that perfect, crispy texture and beautiful golden color. Imagine the smell in this room. It's like popcorn, but sweeter. At this stage, a touch of sugar, salt, or even honey is added to the flakes, depending on the recipe. For glazed flakes, they're coated with a thin layer of sugar syrup that caramelizes right in the oven. How many crunchy flakes could you eat? Fun fact, there's even a championship for speed-eating cornflakes, and the record stands at 16 ounces in just 1 minute. Crazy, right? Now watch as countless hot, crispy flakes roll off the conveyor belt. But not all of them make it into the boxes, only those that pass quality control. Special machines check their shape, thickness, and even the sound they make when they break. Seriously, that's a real quality measure. Once the flakes are ready, they're cooled and packed into bags. The machines automatically weigh each portion, seal it in foil-lined bags to keep it fresh, and place it into cardboard boxes. It takes about 3.5 ounces of corn to produce 1 box of flakes, but growing that amount of corn requires 5 gallons of water. Here's a fun throwback. In the 1980s, a British company tried selling cornflakes in cans, like soup. But the idea flopped because customers thought it looked too weird. Almost 100% of cornflake boxes are made from recycled cardboard, and the printing is done with soy-based ink. Here we are, standing next to the warehouse filled with ready-to-go products. Just imagine, these boxes of cornflakes are about to head out to every corner of the globe. They'll be breakfast for kids in the United States, snacks for students in Europe, or even a key ingredient in desserts across Asia. Fun fact, cornflakes were actually invented in the United States, but today they're a hit in over 180 countries worldwide. Modern factories take eco-friendliness to the next level. Leftover corn from processing gets repurposed as livestock feed, and the cardboard boxes? They're made from recycled materials. Oh, and here's a surprising twist. In some farming communities, cornflakes are actually used as cattle feed.
farmers discovered that cows love this stuff.
Cornflakes have even made it to space. They were included in the diets of American astronauts during NASA missions. Every year, more than 6 billion servings of cornflakes are consumed worldwide. That's enough to feed the entire population of Earth breakfast for 3 weeks straight. And here's something crazy. Listen closely. If you place a magnet near cornflakes, they might actually move toward it. Why? Because cornflakes are fortified with iron, an essential nutrient for human health. Have you tried it yourself? Drop a comment and let us know what happened.